All right, so now that we've introduced ourselves to the logarithmic function, what we're going to be doing in 6.5 is taking a look at some algebraic properties. We know its properties in terms of its graph and that it serves as the inverse of the exponential function, but it turns out that there's some algebraic properties that are very useful for us and kind of unique to the logarithmic function. There's actually 6 of them. All right, and the first 2 are what I playfully call the inverse properties. The first one is log base a of a to the x is equal to x, and the second one is if I take a and raise it to the log base a of x power, what we get is x. So what the heck is going on here? Well, recall back in 6.2, right, when I took a function and I composed it with its inverse, right, the result of that composition was x. They basically undo each other, and we could flip that around. If I took the inverse function and composed it with its function, then what we get is x. And that's basically what's happening here. So in terms of numbers and letters, let me get rid of the a for a moment. If I let f of x equal, let's say, 7 to the x, then its inverse function, right, would be log base 7 of x, right, from what we've learned. So if I want to take a look at the inverse function composed with f of x, right, that would be f of negative 1, right, of f of x, which becomes this of 7 to the x power. So this is replacing that right there. So we get log base 7 of 7 to the x. And of course, we already know what the answer is supposed to be, right? Because by theory, when I compose a function with its inverse, what I get is x. So that's all we're basically saying here. So if my exponent is base a and it's the input of my logarithm of base a, essentially these two guys wipe each other clean and we're basically left with the x that's up there. That's all that's saying, and here it is in action with a equal to 7. Doing the other way around, right, if I do this composition again, we know the answer is supposed to be x, but here what we get is this and becomes this, and so this becomes the input for that function. So we have 7 to the log base 7 of x, right? And so all of these are equal to x. So if I take 7 and I raise it to the log base 7 of x, that all cancels out and we're left with x, right? And so that's all that's saying there. So if I have base a and in the power I have log base a, these guys undo each other and we're basically left with x. So I call these the inverse properties, right, of our logarithms, right? And it basically comes down to their composition. So the challenge is seeing that. So in the first one, I have base 2, but I have 32. So right now, I don't quite have that inverse property. But we do know that 32 can be written as 2 to the 5th. And so once I make that rewrite, right, I have an exponent base 2. It's being placed inside, or it's being composed with a logarithm of base 2. So everybody wipes out, and what we're left with is 5. So log base 2 of 32 is 5. Or a quick check, if I take 2 and I raise it to the 5th power, what I get is 32. So we can kind of verify it that way as well. Again, here it looks like all bets are off because our base is 3 and we got 1 over 27. But if we rewrite this as 3 to the negative 3, we're in business, right? Because I'm basically composing the exponential function base 3 with the logarithm base 3. So they wipe each other clean and we're left with negative 3. All right, or 3 to the negative 3rd power is equal to 1 over 27. So we can even verify that result using that. All right, so we've got it. Here we have log. There's no base, but that means that the base is base 10. So we're talking about the common log. 100 is 10 squared. So I've got the exponential function 10 being composed with its logarithm. So everybody wipes clean and we're left with 2. So log of 100 is equal to 2. This one's actually easy to check because log is on our not only can I just check it, right, 10 to the second power is 100, but we can even put log of 100 on my calculator and verify that it's actually equal to 2. So we can see it on technology, but here what I'm doing is using the idea that I'm composing an exponential function with its inverse. So using the inverse property, they wipe each other clean, we're left with 2. Natural log of 1, well again what we're basically talking here is we have base e, and 1 is e to the 0 power. Right? As a matter of fact, 1 is anything to the 0 power. So in this case, I'll use e because my base is e. So my exponent's base e, my logarithm's base e, they cancel each other out, and we're left with 0. So again, there's the inverse property. If I go to my calculator and say the natural log of 1, right, what I get is 0. All right? And of course, that shouldn't be as any surprise because we know the point 1, 0. If we were to graph the natural log of x function, we know that it's going through the point 1, 0. So kind of verifying that both, we know it happens graphically, we know it happens with the flip-flop of the point, and now we're seeing it basically happen with our inverse property if we rewrite it in the proper way. And again, same here, what we've been using is that version, but here we got this version. So my base is e, and I'm raising it to a logarithm of base e. So everything is going to cancel out, so what's left is 2, inverse property. My base is 10, the power of the log is base 10, right? And so again, they wipe each other clean, and we're left with 5. All right, and again, these are easy to check since e and base 10 are on my calculator, right? I'm using the inverse property, but if we use the calculator, right, if I take e and I raised it to the natural log of 2 power, right, what I should get is 2. And lo and behold, I do. If I take 10 and raise it, 10 and raise it to the log of 5, what I should get is 5. All right, and so the technology is basically verifying what we're seeing using the properties. So if you compose a function with its inverse, basically everything wipes clean and you're left with basically the input. All right, so there you have it. All right, so there's your inverse properties. So there's 2, right? We got 4 more along the way, and these ones are biggies. All right, so we'll do those in a new video coming soon.